Ladies and gentlemen, once again, hello and welcome. Coming to you not quite live from One Take Studios, where today's topic is solving multi-step equations. And here is where life gets a little bit interesting. So we want to make sure that our brain stays focused while we are solving. So these are going to be linear equations. That means that there's nothing super crazy going on, but we might have addition and multiplication, or division and subtraction in the same equation, which is okay. Questions to keep our brain focused. We would like to know, where is the variable? What is with the variable? How is that thing attached to the variable? And how do I break the attachment? With the goal being I want to get the x by itself or the variable by itself. That means I need to break everything that's attached. And today we're going to see multiple attachments to our variable. This idea of unwrapping our variable, if you saw one of my previous videos, this is going to be kind of a big deal today. That if you unwrap a gift, what you are doing is you are undoing everything that somebody else did in the reverse order. So when we unwrap our variables today, we're going to be undoing everything that is done to the variable in the reverse order. In other words, order of operations, undoing it backwards. So let's look at what that could be here. First example is 2x minus 5 equals 3. Where's the variable? Boom, it is right there. What is with the variable? A 2 and a 5. Not the 3. The 3 is over on the other side. But we have a 2 and a 5. How is the 2 attached? That's attached through multiplication. That's 2 times x. And how is the 5 attached? That is attached through subtraction. Okay, we need to break both of those attachments. We know how to break multiplication with division. We know how to break subtraction with addition. But which one do we do first? If we are unwrapping the x, we would start with the last thing that was done. So order of operations, the last thing in order of operations is adding and subtracting. So because of that, that becomes the first thing that we undo. All right, so since minus 5 would have been the last thing that happens to the x, because you would do multiplication first, then subtraction, it is the first thing we undo. But again, we are doing the same thing to both sides of our equation. There's our equal sign. Same thing on both sides. I want it to stay equal. What's going to happen when I do that? Well, let's see. That gives us, there's our 2x. These guys are opposites. Boom, gone, undo each other. There's my equal sign, and 3 plus 5 makes 8. Dun, dun, dun. Now it's maybe something that we are a little bit more comfortable with. We only have one thing with the x, so I can still find the x. I see the 2 is still attached to it. I see it's 2 times x. And again, how do I break that attachment? I break multiplication through division. All right, so again, times 2 divided by 2, break, undo. There's x by itself, and 8 divided by 2 is 4. 4 will be my answer. That's it. That's the plan. Does it get more complicated? Oh, probably. Can we do this? Yes, but keep your brain focused, all right? Keep your mind where it needs to be. If your brain goes on automatic pilot while we're looking at this, it's probably not a good thing. All right, so a few more examples here. Next one up, again, keeping our questions where we can see them, keeping our example where we can see it, because oftentimes an example can be useful as well. All right, so we have here, oh, let's see, something causing shade on our screen. Let's move that a little bit, shall we? That's better. Okay. New equation, new example. X divided by negative 4 plus 3 equals 1. Where's the variable? Right there. What's attached? A negative 4 and a 3. The negative 4 is attached how? Through division. The 3 is attached how? Through addition. How do I break those attachments? Well, I'm going to need to multiply, and I'm going to need to subtract to undo and undo. Which one do I undo first? Again, we are unwrapping the variable. If you're really not sure what I'm looking at, check one of my earlier videos for solving. I gave a really good example of this that included actually unwrapping a present. So with this, again, we are undoing everything that's happening to the x. The last thing in order of operations is plus 3. So that becomes the first thing that we will undo. So we will do a minus 3 on this side and a minus 3 on this side. Again, keeping it equal, doing the same thing on both sides of the equation. Make that go away. Opposites undo each other. Gone. I've got my x still over negative 4. Still have my equal sign, and 1 minus 3, careful with the negatives. I've got $1, I need to spend $3 I'm missing $2, I'm short $2, I would owe $2 potentially. Again, negative numbers and owing money kind of go together if that helps your brain. What do we still have left? The 3 is now gone, but the negative 4 is still attached. How do I break division? Through multiplication. Please watch your signs again. Be careful. We're dividing by negative 4. To undo that, we will multiply by negative 4. All right. Undoing, dividing by negative 4 means we are multiplying by negative 4. And always doing the same thing on both sides. What will this get us? Multiplying by negative 4 undoes dividing by negative 4. There's x by itself. Yay, happy day. And again, this is multiplication. Remember, we multiplied here, we're multiplying here. Negative 2 times negative 4 is positive 8. There we go. Nice job, people, nice job. Okie dokie, dun dun dun. By the way, if you are feeling brave at any moment, pause the video, stop the video, and you try the example, and then turn the video back on, and see if you get the same thing that I did. That actually is a really good idea, because did you know that when I talk for you and I explain for you, your brain thinks, hey, that makes sense. However, your brain understanding my work is not the same as your brain being able to come up with the work yourself. So anytime you're feeling brave, please pause me, all right? Stop the video, try these, and then turn the video back on to see what you did. I guarantee you will learn more that way than just listening to me. Next one. Here we go. Again, we've got, here's my x. Where's my x? Right there. And what is with the x? I've got a 2/5 and a 4. How are they attached? Well, that 4 is being attached through addition, and that 2/5 is a fraction. Ooh, we talked about that being a combo sort of thing. That's a combo meal. That's 2 operations in one. That's a multiplication thing and a division thing at the same time. So, where do we begin? Again, looking at the attachments and how do we break them, but we are unwrapping what is happening. The last thing in order of operations is adding and subtracting. So that's the first thing that we will undo. So if this is plus 4, it's a positive 4, I can undo it with a minus 4 or a negative 4. Always ask yourself, will this actually undo this number? Because if the answer is no, you need to rethink it. But yeah, 4 minus 4, that's going to undo that. That's going to go away. And again, same thing on both sides of the equal sign. I want to do a minus 4 over here as well. So, gone, undo. We have the 2/5 times the x left here. We still have our equal sign. And 12 minus 4, last time I checked, was 8. Okay. We have to get rid of this fraction still. We broke one of the attachments. We got to break another one. If you remember what I said again in one of my previous videos, this is a combo meal. This is 2 things happening. This is 2 times x. How do I break 2 times x? I break multiplication with division. So since this was times 2, I'm going to divide by 2. Doing the same thing to both sides, dividing by 2 on both sides. This, we said this part is division. So this is dividing by 5. How do I undo dividing by 5? With multiplication times 5. But again, if I can multiply this side by 5, I'm going to multiply this side by 5 as well. Again, undoing, same thing on both sides. And I might put this in parentheses just to make it look a little bit less crazy, maybe. I don't know. Maybe you think it looks more crazy. I don't know. So, times 2 divided by 2 will undo itself. Times 5 divided by 5 will undo itself. Miracle of miracles, there is the x by itself. Here's my equal sign. And what do I do with this? Again, if I view this as a combo meal, this is just 2 things happening. This is 8 times 5. What's 8 times 5? That's going to be 40. And what happens if I take 40 and I divide it by 2? That gives me 20. There is my answer, right there. Ta-da! Okay, so notice that each example here is a little bit different, which is why these are worth looking at all the way to the end of the video, I promise you, because I got 2 more examples coming at you. So here's the second to last example, and what is up with that? That is very interesting, because you see, ladies and gentlemen, I have an x and an x, and every other example here just had the one x. So what do I do if there's 2 x's? Please note to self, this is me making a squiggly, happy notification to self. These two things are on the same side of the equation. This is a very important observation. Because they are on the same side, I am allowed to simply combine them. I can put them together. They are like terms. Do you happen to remember, if I see a variable with no number in front of it, what number is supposed to be here? Do you remember that? That's supposed to be a 1. So that's 7x minus 1x. Again, if I don't see a number, it's just a 1. So if I have 7 x's and I take 1 x away, how many x's will I have left? It's kind of like marbles. If I have 7 marbles and I take 1 marble away, I will have 6 marbles left. So 6 marbles, 6x is what we have left. Still have the equal sign, still have the negative 18. Well, now it looks a lot better. All right, now now we can go back to our questions. Here's the variable, because here we had a couple of variables. So now we have one variable. We have a 6 is attached to it. How is it attached? Through multiplication. How do I break that? Through division. All right, breaking the attachment here, breaking the attachment here. And what will that give us? Well, again, multiplying and dividing, that will undo itself. There's the x, and negative 18, watch your signs, negative 18 divided by 6 is negative 3. Okie dokie. All right, well, that's not too bad. One more example, and I promise you, again, every example is a little bit different, so hang in there. This is going to be worth looking at. Oh, what is that? That's kind of weird looking. All right, I'm going to show two things to your brain, because your brain might know one thing, but your brain might know another. So I'm going to show your brain two things to see which one that your brain likes better. This says 2 times, in parentheses, x minus 3 equals 12. Will my question still work with this? Yeah, it kind of will, because there's the x. I found the x. What's with the variable? It's a 2 and a 3. How are they attached? Well, that says 2 times this mess here, and that says minus 3, so I know what the attachments are. So the question now becomes, how do I break them? Now, here's the thing. If we are unwrapping the variable, order of operations, parentheses comes first, and then multiplication. So if I'm going to unwrap and undo those things, I'm going to start at the end. Instead of starting with the parentheses, I might start by undoing the multiplication. So how do I undo a times 2? Well, again, this is one way to think about it. I can undo times 2 with dividing by 2. These guys will cancel each other. Times 2 divided by 2, gone. What's left? Just an x minus 3 equals, and 12 divided by 2 is 6. Now this looks a lot more manageable as my camera comes back into focus. I'm saying, all right, this 3 is still attached. How is it attached? Subtraction. How do I break that? With addition. Plus 3 on this side. Again, same thing on both sides of the equal sign. Plus 3 on this side. Trying to break that attachment. Gone. There's my x by itself. And 6 plus 3 is 9. All right, now, I know some of you are screaming inside right now. Well, maybe you're screaming outside. I don't know. Same problem, because some of you see something else here. So 2 times, again in parentheses, x minus 3 equals 12. This is correct. This is going to be correct as well. What do you see? Because some of you are probably looking at this and going, hey, I know what this is. This is something called the distributive, it's a long word, property. Distributive property. That says if I've got something multiplied times a sum or a difference, which is what this is, a difference, I can distribute the 2. Now, how does that work? Well, this is still 2 times something, so this is still multiplication. I like to think of the distributive property as launching water balloons. Everybody gets a water balloon. There we go. Everybody gets a 2. We are multiplying again. This is 2 times x, otherwise known as 2x. This is also 2 times a negative 3. Again, I can view this as a minus 3, but I can also view this as a negative 3. What is 2 times negative 3? Negative 6, or minus 6, depending on how your brain is looking at that. And that still is going to equal 12. Now, we can still approach this the same way we were doing our original examples, breaking everything around it. Next, we would do the plus 6, because again, order of operations backwards. We start by undoing addition, subtraction. Plus 6, both sides of the equal sign. There we go. Gone. Those undid each other. They were opposites. There's my 2x. There's my, 12 plus 6, big number, 18. 18. And one left attachment to break, one left, one less. Dividing by 2 because that was times 2 and we are breaking it. Breaking attachments all over the place here. 2 divided by 2, gone. There's my x by itself. And 18 divided by 2 is 9. Look, I promised you, same answer. So you can think about it this way if you like this, but you can also think about it this way if you like this. Most important thing with this, practice, patience, don't give up. All right, you got this.